Once again, parts fabricators have demonstrated PM's versatility and unique ability to challenge competing technologies. Through innovative design and shape complexity, they are implementing strategic tools to overcome challenges and provide solutions for end users. Acknowledging outstanding parts fabricators provides an opportunity to raise the bar, to chase innovative ideas, and to work together to harness the full potential of this advanced manufacturing technology. Now it is time to recognize the grand prize winners as chosen by this year's judges. APG Sintered Metals, a division of Nichols Portland Incorporated, received a grand prize in the automotive engine category for conventional PM components for a 20-degree slanted oxygen sensor boss. This 20-degree slanted oxygen sensor boss is used on a V6 pickup truck catalytic converter. The stainless steel sensor boss is produced by compacting to near net shape, delubricating in a low-temperature belt furnace, and sintering at 1315 degrees Celsius in a high-temperature pusher furnace in a hydrogen atmosphere. The SS409L material was selected for its weldability, adequate corrosion resistance, and relative cost compared with other higher alloy content materials. The only secondary operation is threading the ID and machining the counterbore in a high-speed automated lathe. Controlling the fill depth and compaction ratio across the lopsided flange and hub requires a bolt-on angled 3D metal printed die extension and custom feed shoe. A green density of 6.55 grams per cubic centimeter is targeted and sintered to a minimum density of 7.2 grams per cubic centimeter. The sintered density prevents surface-connected, interconnected porosity between the ID and the outside surfaces and enables the parts to meet a 100% leak test at the customer's assembly facility. Burgess Norton Manufacturing Company and Customer Means Industries received a grand prize in the automotive electric vehicle category for conventional PM components for a notch plate and pocket plate. Used in an electromechanical e-axle disconnect between the rear wheels and the rear motor of battery electric vehicles, this notch plate and pocket plate have increased vehicle efficiency with a 10% increase in vehicle range. Both parts are made from FLNC 4408 to a density of 7.1 grams per cubic centimeter. They are compacted, sinter hardened, and tempered, and hard turned for geometry and tolerance refinement. This is followed by cleaning and the application of a rust preventative treatment to protect the parts during transport to the customer and subsequent assembly operations. Both parts rotate in the assembly and have balance requirements that are maintained through a combination of tooling geometry, die fill compensation, and sectional densities to avoid the need for a balance correction operation. Both parts have flatness requirements maintained during sintering. Combined, the notch plate and pocket plate weigh 1.5 kilograms, adding 3 kilograms of PM to the battery electric vehicle. PM provides a 9% weight saving, which also improves battery life. As battery electric vehicles adoption increases, the potential total mass of PM content using this new type of clutch may be significant. GKN Sinter Metals and customer Ford Motor Company received a grand prize in the automotive transmission category for conventional PM components for a differential gear set locking ring. This differential gear set locking ring is used in a rear axle electronic locking differential in 3/4 and 1-ton pickup trucks. The gear set passed full validation for all application tests, including full axle dyno, fatigue, impact, differential seizure, spline interface, and full vehicle durability. The parts, a pinion gear, 2 side gears, and locking plate are compacted, sinter-carburized, net-shape powder forged, quench hardened and tempered, and machined to tight dimensional and surface finish requirements. The locking plate is a non-symmetrical, multi-level, thin shelf thickness forging. Innovative tooling and heating concepts were employed in its production, with extra material added as needed for forging tool safety factors and to control distortion during the quench and temper operation of this varying thickness part. Minimal secondary operations are needed due to the precision of the forging of the 4 differential gears of the gear set. AGMA Class 7 is achieved on the bevel gears and AGMA Class 6 on the side gear splines. The total set weighs just over 5.4 kilograms. Given the added durability of powder-forged gears, this technology is well positioned for future systems, including hybrid and battery electric vehicle applications. Indomim Private Limited received a grand prize in the hand tools recreation category for MIM components for a keeper release. Door locks must sustain frictional force and wear and tear during operation. MIM was selected for this keeper release used in a sub-assembly for safety door locks. The keeper release is made using MIM 17 4pH stainless steel, and the parts are given an H900 temper to achieve an ultimate tensile strength of 1200 megapascal and a minimum apparent hardness of 35 HRC. This 60mm long part has a square central cross-section with rectangular blocks at each end. There is also a 1.65mm thick H-shaped projection part way along the central section. The part has a minimum wall thickness of 0.62mm and a maximum wall thickness of 2.54mm. Secondary operations, including sizing to correct distortion and the drilling of one hole. MIM was selected as the best technology as it gave the customer the freedom to design a high-performance part that had high material utilization and repeatability, resulting in cost and efficiency advantages. Meeting weekly customer requirements was not manageable or cost-effective with other technologies. Hangzhou Sino MIM Technology Company Limited received a grand prize in the electrical category for MIM components for a heatsink. This heatsink is used in an optical communication 5G base station photoelectric module bracket for heat dissipation. The part is made from an 80 tungsten, 20 copper duplex pseudo alloy. The material has strict requirements for the coefficient of linear expansion, thermal conductivity, density, and apparent hardness. The feed material is a nano-grade metal powder, so the mold requirements are very high. The feed material contains a low-temperature wax, and the molding process requires a special screw. The design has one mold with two cavities. Solvent debinding is used, and sintering is performed using a hydrogen atmosphere. The heatsink was previously made from a copper-infiltrated tungsten billet that required computer numerical control and wire electrical discharge machining, complex and expensive processes. The MIM parts can be made without the need for secondary machining. Additionally, the MIM process reduced the cost by more than 45%, and the production cycle time was shortened. Hangzhou Sino MIM Technology Company Limited received a grand prize in the hardware appliances category for MIM components for a screw. This screw for a juice maker was originally designed as a plastic injection molded component that easily deformed, had poor wear resistance, and a low service lifetime. Redesigned as a mass-reduced hollow interior screw, utilizing multiple MIM components made from food-grade stainless steel was the perfect solution. A solid metal iteration of the design weighed nearly 860 grams, which was not ideal. The screw was redesigned, divided into several small parts, and the hollow interior structure reduced the part mass to 470 grams, a 45% reduction. The sintered density of the parts is greater than 7.85 grams per cubic centimeter, and the screw can survive a neutral salt spray test of 120 hours. The conversion from plastic to MIM has led to a better surface finish and mechanical properties, and a significant improvement in the lifetime of the product. Azoth received a grand prize in the industrial motors, controls, and hydraulics category for metal AM components for a fluid matter exchanger. While relatively simple in appearance on the outside, this fluid matter exchanger is extremely complex on the inside. The part is binder jet processed using 316L stainless steel powder, and the as-printed part is about 20% larger to account for shrinkage during sintering. Live setters are printed right underneath each part in the build box. The live setters are designed to fit the complex bottom of the part and allow the part to be sintered vertically. Additional printing enhancers are printed within the build box to facilitate the depowdering operations. The hollowness, internal channels, internal filters, and other complex features of this fluid matter exchanger make it a part only viable through additive manufacturing. There are 21 threaded holes directly printed on the part. Internal filters were added within the internal channels to control the fluid turbulence as the matter travels through the part. Some post-processing is performed by the end user, such as welding an end cap and connectors to the fluid matter exchanger. The customer performs flowability as well as pressurized leak testing of the parts. Guangzhou Sino-MIM Technology Company Limited received a grand prize in the medical, dental category for MIM components for a titanium alloy kneecap bracket. This titanium alloy kneecap bracket is used to repair or replace a human kneecap. The part weighs about 74 grams, nearly half the weight of a traditional stainless steel kneecap. Additionally, some patients have endured adverse effects from stainless steel kneecaps when used over a long period of time. The parts have a density of 4.2 grams per cubic centimeter and a tensile strength greater than 900 megapascal. The surface of the parts is polished to a mirror finish to provide superior wear resistance. Traditional stainless steel kneecaps are made using computer numerical control machining, have long lead times, and are very expensive. MIM has reduced the cost by about 50%, solved supply chain concerns, and the titanium alloy kneecap has good biocompatible properties and is much lighter. 3DEO Incorporated and Customer USB Medical received a grand prize in the medical, dental category from Metal AM Components for a surgical implement articulation joint and pivot. This articulation joint and pivot assembly is part of a surgical implement used for performing laparoscopic heart surgery. The instrument lifts the heart gently, allowing the surgeon access to the back of the heart. The three-part assembly is built from 17-4 pH stainless steel using a layering process in which 100 micrometer layers of powder are deposited, bonded, and machined on a per-layer basis until the parts are fully built. Once part printing is complete, parts are separated from the surrounding supporting material and staged for sintering. After sintering, threads are machined to align the angle of articulation and degree of freedom of the pivot. The customer reams holes and installs pivot pins, laser welds the joint to a shaft, and grinds the pivoting joint assembly to the finished diameter. Demand volume does not warrant MIM tooling investment, and machining is too costly and time-consuming. Metal AM allows the customer the ability to make future design changes without consequence. Tritech Titanium Parts LLC received a grand prize in the military firearms category from MIM Components for a titanium ring clamp. Used in a mounting device for a magnifying scope on rifles, this titanium ring clamp replaces a heavier, machined aluminum alloy version. This titanium part has 4 times the tensile and yield strength of the aluminum alloy, allowing the customer to redesign the part to reduce mass. Additionally, the titanium alloy allows the mounting screws to be tightened to twice the original level. Each ring clamp is made of 2 parts, an inner ring and an outer cage. The roundness of the inner ring is crucial to hold the magnifying scope uniformly and not mar the housing. The parts are molded separately, assembled in the green state, and then sintered to create one ring clamp. Although there is an interface present, the 2 parts sinter bond together, providing robust strength through the face machining of one side of the clamp and threading of holes during secondary operations. The entire finished assembly receives a flat black, thin film protective ceramic coating by the customer. Ladies and gentlemen, these are the winners of grand prizes in the 2023 PM Design Excellence Awards competition. Please join us in saluting their achievements as we invite company representatives to come to the stage to accept their awards.